second part of the AOD series. In this part I will be discussing about tangent from external point, minimum or shortest distance, trick to find equation of tangent directly from a second order curve, and intercept made by tangents. So let's start. So we assume a curve like this. Now we have to find, let us assume this point to be x1 y1. Then we have to find the tangent from any external point, let us say hk. So what should we do? So first of all you have to put the point x1 y1 on the curve, then you will get one equation. Then you have to, in the second step, you have to equate the slope, that is dy dx at the point x1 y1 should be the slope of the tangent, that is k minus y1 divided by h minus x1. So this is second equation. Now you will solve those and get the required answer. So let's start with an example. So the question is coordinate of a point of the curve y equals to x square plus 3x plus 4, the tangent of which passes through origin. We have to find the tangent. Now what we have to do is to find the point from which the tangent on this curve passes through origin. So let's start. So let us assume the curve is like this. So we assume one point here, that is x1 y1. So first we need to put this point on this curve. So what we get, that is y1 equals to x1 square plus 3x1 plus 4. Now the second part is equating the slope. So first of all we need to find dy dx. So dy dx is 2x plus 3 here. So dy dx at the point x1 y1 is 2x1 plus 3. So 2x1 plus 3 should be equal to the slope of tangent. It passes through origin, that is 0 0. So the slope of the tangent is y1 minus 0 divided by x1 minus 0. Now we solve 2x1 square plus 3x1 equals to y1. This is the second equation and this is the first equation. From here we know that y1 equals to x1 square plus 3x1 plus 4. Now we put it, that is 2x1 square plus 3x1 equals to x1 square plus 3x1 plus 4. Here we get, so x1 square minus 4 equals to 0. From here we get two values of x1, that is x1 equals to 2 and another is x1 equals to minus 2. From x1 equals to 2 we get y1 equals to 2 square plus 3 into 2 plus 4, that is 4 plus 6 plus 4 equals to 14. And from minus 2 we get y1 equals to 4 minus 6 plus 4, that is 2. So from here there are 2 points, that is x1 y1, that is 2 comma 14, and another point is minus 2 comma 2. So that's the required answer. Now coming to minimum or shortest distance part. So minimum distance between two curves or greatest distance between two curves both lie at the point where tangents are parallel to each other. So it is the most important point. So let's assume the two curves are like this, one is like this and other is like this. So we need to find out the minimum distance between these two curves. So where it will happen, minimum distance. So we will get the minimum distance at the point where tangents are parallel to each other. Let's assume at this point tangents is like this and this point tangents is like this. So we will get minimum distance at these 2 points. Other thing to remember, if both the curves are inverse to each other, let us assume two curves, that is e to the power x and ln x. They both are inverse to each other. So in that case, we found out, to find out the distance between minimum distance, we need to find the distance between one curve and the line y equals to x. That means as both the curves are inverse with respect to, as both the curves are mirror image with respect to y equals to x line. So we will take one question on that, and here also we need to find the dy dx and equate it from both sides. So let's come to the question. So question is, find the minimum distance between the curve y equals to e raised to the power x and the curve y equals to ln x. So first of all, we draw these two curves. So here, so y equals to e raised to the power x is curved like this, and this is y equals to x line, and the curve y equals to ln x is like this. So you see that these two curves are inverse to each other. So now what we have to do is to find the distance between y equals to x curve and one of the curve, that is e raised to the power x or ln x. So we take ln x and y equals to x. Now we have to equate the slope. So we know the slope of line y equals to x is 1. For y equals to ln x, so its slope is d dx of ln x, that is 1 by x. So we equate both this. So 1 by x equals to 1, and we get x equals to 1. So where x equals to 1, then y equals to ln of 1 equals to 0. So the point we get is 1, 0. That is exactly that point, 1, 0. Now you should know that the perpendicular distance is minimum distance. So what we have to do is, we have to draw perpendicular from this point to the curve y equals to x. So we find this perpendicular distance. Now the perpendicular distance from y minus x equals to 0 is determinant of 0 minus 1 upon under root 2. So that is 1 by root 2. This is perpendicular distance. Now total distance between these two curves is 2 times of this. So distance between e raised to the power x and ln x equals to 2 into d, that is 2 into 1 by root 2. So that is equals to root 2 unit. So that's it. Now coming to the method of finding the equation of tangent directly. Now the thing is, for any second degree curve, you should know that any second degree curve f of xy can be represented as ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals to 0. So if you want to find the equation of tangent directly, then you have to know the point of tangency, that is x1, y1. If you know that, now you can easily find that equation of tangent. What you have to do is, you have to transform this x square to x1, y square to y1, 2x to x plus x1, 2y to y plus y1, and xy to xy1 plus yx1 divided by 2, and put this to the equation again, and you will get the equation of tangent directly. But remember that you need to know that point x1, y1 in which you are finding the tangent. Now coming to the last part, that is intercept made by tangents. So here we assume a curve like this. Now we are finding the tangent at this point. So So let us assume the tangent is like this and the point is x1 comma y1. So tangent at this point is y minus y1 equals to dy dx into x minus x1. So here m equals to dy dx, so let's represent it by m. So y minus y1 equals to m times x minus x1. Now we learned it in the previous part, that's part 1. So if you don't know, then see part 1. So we have to find these 2 points, that is the intercept part. For this, now at this point, that is, it is completely on x-axis and this is completely on y-axis. For here, that is y coordinate equals to 0 and here x coordinate equals to 0. So in the equation of tangents, we put y equals to 0 first. So putting y equals to 0, we get x coordinate. So when we put y equals to 0, we get minus y1 equals to m into x minus x1. So minus y1 equals to mx minus mx1. So x is mx1 minus y1, that is mx. So x is x1 minus y1 upon m. So that is x coordinate. So point of this is, so coordinate of this point is x1 minus y1 upon m, comma 0. For this point, we put x equals to 0. When we put x equals to 0 in this equation, we get y minus y1 equals to m minus mx1. So y equals to y1 minus mx1. So that is y coordinate here. So coordinate of this point is 0, comma y1 minus mx1. So that's it. So x intercept is x1 minus y1 upon m and y intercept is y1 minus mx1. So thank you and best of luck for JEE Main 2020.